Now we're going to apply a little bit of algebra to some of the things we've been doing with graphs. Now we have the graph that forples when x doubles. Okay? Now if y forples when x doubles, then what can we say? If x2 equals 2 times x1, okay, where x1 and x2 are two values of x, then we have to have that y2 equals 4 times y1. Okay, where y2 is the y value that corresponds to x2, y1 the y value that corresponds to x1. Now that's implicit, but y2 is the graph value for x2, y1 is the graph value for x1. Another way of saying that is x1, y1, and x2, y2 are on the graph. Okay, just to clarify that that's what implicitly is meant by this, that y2 corresponds to x2, y1 corresponds to x1. Okay, now, next hypothesis, and you don't understand necessarily where this came from, it just came from me, but it corresponds to the situation, so let me just draw a little line there to demarcate this. So, if y forples when x doubles, I've said that this represents a power function. Now, if I'm saying that the power function is in the form y equals x to the p, then my question is, what is the value of p? Okay, so that's something you should stop and think about for a minute before you look at the answer. Okay, I don't expect you to invent this proof, although some people might well be able to do so, but I'll say a few leading questions. Okay, now, if y equals x to the p, then what's the expression for y2 divided by y1? Okay, if y equals x to the p, what's y2 divided by y1? Well, it's implicit in what's been said here, and it's almost explicit. It's implicit, though, that y2 is x2 to the p. If y equals x to the p and y2 corresponds to x2, then y2 has to be x2 to the p. And if y1 is the y value that corresponds to x1, if this is the case, y1 has to equal x1 raised to the p. Well, if that's so, then what's y2 divided by y1? Well, y2 divided by y1, as you see, is x2 to the p divided by x1 to the p. Now, I asked, how would we simplify that? According to laws of exponents. We got into a little digression about negative exponents that I won't talk about right now. And that was a good little digression. It wasn't a bad suggestion. That would lead to one simplification. But the simplification that I'm looking for is this. x2 to the p divided by x1 to the p equals x2 over x1 raised to the p. Because any fraction raised to the p is the same as the numerator to the p divided by the denominator to the p. Okay, when you raise a fraction to a power, it's the same as raising both the numerator and denominator to that power. And that's something that you're familiar with. People kind of hit themselves in the forehead when I did this. But it's not necessarily the kind of thing in this context that you're immediately going to think about. When you've done a little more algebra, very much likely you will. Okay, so now, what's our hypothesis here? Well, that x2 is 2 times x1, and that y2 is 4 times y1, because that fits the original condition. So, if x2 over x1 is 2, which simply indicates that x has been doubled, And y2 over y1 equals 4 because y forples when x doubles. Excuse me. Then, since we have this, and somebody saw this very nicely, y2 over y1 equals x2 to the p over x1 to the p, so that y2 over y1 is x2 over x1 to the p. Well, if y2 over y1 is 4 and x2 over x1 is 2, that means that 4 has to equal 2 to the p. y2 over y1 equals x2 over x1 to the p. y2 over y1, as we can see, is 4 because y forples. x2 over x1 is 2 because x doubles. So 4 equals 2 to the p. Now, what's the value of p? Well, everybody, I think, pretty much saw this immediately. What power you got to raise 2, the power to which you have to raise 2 in order to get 4. I was about to say the power you raise 2, and I'll be talking about ballet skirts. So, in general, this is not an equation that you're expected to be able to do after Algebra 1 and Geometry, or even after Algebra 2, much less just Algebra 1 and Geometry. So, I can't ask you to solve this equation for p. That's something that you might well see in Algebra 2, but you might not. You are going to see it in an analysis course, and you'll get good at solving that kind of an equation if you challenge yourself. Okay, so this is not an equation you could solve. If this is 5 equals 2 to the p, you wouldn't be able to solve it. Now, you might be able to go to the calculator and put in different powers of 2 until you get close to 4, and you might come out pretty close, 2.23 or something like that. But that's just a rounded off version. It's actually the log of 5 divided by the log of 2. And again, you don't know that. You wouldn't know that. We take the exponential graph that we've constructed in class and switch the x's and the y's, we get the log graph. And then you could estimate the log of 5, and you could estimate the log of 2, and you could divide them and see about what the power of p ought to be. But that'd be an estimated solution, and we're not going to go there. There's no need to do that at this point. You'll get a pretty good picture of that from analysis. Okay, well, anyhow. So usually if I say y increases by factor 5 when x doubles, you're not going to be able to tell me exactly what the power of p is. You're not going to be able to solve that equation. If it's not a whole number power, then you're probably not going to be able to solve it. There are some other half powers if the base here is a square, and we don't want to get into that. Okay. Generally, you won't be able to solve the equation exactly, but this time you can. It's obvious that the power is 2, because 2 raised to the second power is 4. Okay? And from that, it follows that y equals x to the p is y equals x squared. Okay? So now, if y forples when x doubles, you know you have an equation like y equals x squared. Now, that equation can be relabeled. And in general, you're going to get y equals some number times x squared. But the basic idea is that's something that's like a y equals x squared graph. Okay. Now, on homework, you were asked to sketch a graph of y equals x squared. Now, only one person managed a decent graph of y equals x squared. And I found that a little bit surprising. And I believe Mr. Adams, who teaches these courses in high school, found it a little surprising. But it was probably the terminology. And if you don't understand the terminology, the words aren't that complicated. It's mostly because you don't deeply understand the concept. And as I keep saying, you're not going to have to deeply understand these concepts to do okay on the SOL and to do well in high school courses that are really aimed at people of more modest mathematical ability. Still, you know, you're in classes with people who are not by any means stupid, but not everybody has the ability of the people in this class. And people with that ability need to push themselves a little bit. And I try to drop hints here about how you might do that. And you might find other ways too. Okay. And as I said in class, I know it's tough to push yourself when you've got a ton of work to do and you're trying to claw your way up to get all that done. Still, you need to find a way, okay? Without putting a ridiculous amount of pressure on yourself. Okay, well, anyhow, so I even gave you the fact on the statement of the problem that, okay, for x values 1, 2, 3, 4, what are the corresponding y values? And people didn't appear to know what to do about that. You can ask yourself why. And it's simple. You're going to understand it just perfectly well. And you probably already do if it's said right. So if x is 3, what's y? Well, y equals x squared. So 3 squared is 9. And people answered that question immediately and were able to answer the thing. And then you make a table. And then you can graph the numbers on your table, the y versus x. And again, I was a little surprised that people were not able to do that from the statement of the problem, which even said, for x values, I think included 0, 0, 1, 2, 3, 4. What are the corresponding y values if y equals x squared? And then graph this. Anyhow, now you know what that means. Now you should understand that terminology. And when the words ask you to do this, no matter how the words are put together, as long as they're grammatical and in a language that you understand, you should be able to do that. Of course, then this question was accompanied by the question of, if x doubles, by what factor does y change? And you would be expected to take this graph and answer that question. And of course, the answer has to be, since y equals x squared is the function that has this property, and no other function does, because if this property holds, then that's the function. And that function then has to have this property, so that when you graph this, it has to be such that when x doubles, y doubles, and you need to be able to verify that.